The first derivative test tells us how first derivatives affect the shape of the graph. Well, you pretty much know this already because we talked about it before, right? When the first derivative is positive, it means the graph is increasing. And when the first derivative is negative, it means the graph is decreasing. So that's the basis for all of this stuff here. So remember that when the first derivative is positive, your graph is increasing, right? So it's basic, oh, I'm out of space. So it's basically going up, right? And when it's the first derivative is negative, our graph is decreasing, or it's going down. Fine. So what this first derivative test tells us is, all right, let's now look at our first derivative, find the critical points like we did back in section 4.1, and let's look at a sign chart for the first derivative, and let's see what it tells us about those things. So once we find all the critical points, put them on our sign chart, and look at the sign of the first derivative, it'll tell us where the function is increasing and where the function is decreasing, right? Well, obviously, if the function changes from increasing to decreasing, you've got some sort of local maximum. And if the function changes from decreasing to increasing at some point, you've got a local minimum. And if it doesn't change, well, then maybe it's doing this, or maybe it's doing this, whatever it's doing, but you don't have a max or a min. All right, so we can read that off of the sign chart for the first derivative. So you can get a ton of information just from that first derivative. So let me give an example. Function, here's a function, f of x equals 36x plus 3x squared minus 2x cubed. All right, straightforward, right? So we go ahead and we find the critical points. And because we know this is a polynomial, we don't have to worry about where, we do have to worry about the signs, right? But we don't have to worry about this function ever being the derivative not existing because, of course, it's just another polynomial. But we do have to find the roots of the polynomial. So I'm going to set this equal to 0 and solve. So just because it's easier for me, I'm going to take out minus 6. Right? So I'm going to factor that. So it's minus, what did I do? Minus. Yeah, there you go. Like, what? That's not right. That was something wrong here. All right, that makes a lot more sense. Okay. So I pulled out a minus so that my thing there was positive, but then I forgot to pull out a minus from here. All right, anyway, so I have x squared minus 6 minus x minus 6. So this is obviously going to be x minus 3 times x plus 2, right? Okay, so I've got two critical points, negative 2 and 3. All right, great. So I'm going to take those. Now I'm going to do a sign chart. But what I'm going to do is a sign chart. This is the sign chart for the derivative. This is not a sign chart for my original function, right? Okay, this one probably wouldn't be so bad because I could probably do a sign chart for this function without too much trouble. But let's say there was some plus 5 here or something. Then it would be much more difficult to try to, say, figure out what the roots of this function are. Most of the functions that we're going to be using this techniques with, you aren't going to be able to factor or figure out how to deal with in a very nice way. So we really kind of need to figure out the calculus techniques so that we can really get a good idea of the shape of the graph. So this is, and I always like to label my sign charts, so even though I'm kind of out of space here already, this is going to be the sign chart for the first derivative. So here's your first derivative. This one or this one, whichever form you want to use, right? And I'm just going to plug in some numbers. If I plug in x equals 0, okay, I'm going to get something positive. So I know it's positive there. If I plug in x equals 4, okay, I'm going to get something. You can actually, well, maybe it's not so easy to see from here. From here, you can see if I plug in x equals 4, this is positive, that's negative, I'm going to get something negative. Or you can actually work out the number. That's fine too. If I plug in x equals -3, negative, negative, negative gives me a negative. Okay, so now if I look at my sign chart and what we had talked about for the first derivative test, what is this first derivative doing? Here, it's decreasing and then it's increasing. Whoop, that's got to be a minimum. Here, it's increasing and then it's decreasing. That looks like a local maximum. And there I have my answers. So what can I tell you? Often it asks you to write down the intervals of increase and decrease. Write down the maximums and the minimums. Right? So let's do that. So my function is increasing from -2 to 3. And what it's at the actual point, it's neither increasing nor decreasing. So basically we use open intervals for these. My decreasing, I'm decreasing from -∞ to -2, and then from 3 to infinity. Okay, I've got a local minimum at x equals -2, but they're going to want to know what the value of that minimum is, okay? This just tells me where the minimum happens. It happens at x equals -2. It's not telling me the y value. So in order to find the value, which is going to give me the point on my graph, which is the minimum point, the local minimum point, I have to go back to my original function and find out what f of -2 is, okay? So that is going to be the minimum. The minimum is going to be always the y value. So let me see what I have here. I've got 36 times -2 says -72, and then plus 12, and then minus says plus 16. I'm going to write this down somewhere. Oh, this is -44. And then from my local maximum, that's going to happen at x equals 3. And the value of the maximum is going to be 36 times 3 is 108. And 27 times 50 square. 108 minus, what is this? 81? 8, 9, 10, is that right? Yes. 81 is going to be my maximum. So when you do these problems, if you do them for WebAssign, they of course have boxes where you put all this stuff. If you're doing them for the worksheet or on a test or whatever, it's very helpful if you sort of list all the things that you find in a place where I can see it so that I know that you did it all. So if this is over here and that's over here, then it's easy to miss your answers. So we did all this work, but now at least it's in a line and you can read where it is. Because what's going to happen as we continue through this section, there's going to be more stuff that we're looking for. Not just intervals of increase and decrease and mins and maxes.